Hello. Expressed as partial fractions with complex linear denominators. So we've switched here now to complex numbers, but we can actually do all that we can do with real numbers. So first of all, let this denominator x squared minus 4x add 5 equal to 0. And that implies that the solutions to this, I've used the formula, I'm not going to go through that again, is x is equal to 2 plus or minus I. Checking my previous videos, I've actually covered partial fractions for real numbers, and also yesterday I've covered how to solve quadratic equations such as this one, where b squared minus 4ac is less than 0 or negative. So the factors of x squared minus 4x add 5 are x minus 2 add I and x minus 2 minus I. Again, here to get these factors, I've done a previous video just yesterday where I use the factor theorem, and I use this to determine the factors of this quadratic equation. Now we can write that x squared minus 4x add 5 is equivalent to x minus 2 minus I brackets x minus 2 add I. Now for required partial fractions, the required partial fractions must have complex denominators. So we can provide, for complex numerators, we must write that 4 over x squared minus 4x add 5. Now we're going to write our complex numerators. Add this to c add di over x minus 2 add I. Now we can write that 4, well, let's write this line first, let's not skip this step. A add bi times this, so x minus 2 add I, added to c add di times that in this denominator. C add di brackets x minus 2 minus I. And the denominator of all of this is x squared minus 4x add 5. Now because both the left and the right hand side had the same denominator, x squared minus 4x add 5, we can write that 4 is equivalent to a add bi x minus 2 add I added to c add di x minus 2 minus I. So when we have x is equal to one of these options, so we'll take the positive, so 2 add I, then this becomes 4 equivalent to c add, not equivalent but equal to c add di to minus 2I. So what I've done is substituted x is 2 add I in both here and here. In this case, it cancels. Is that correct? We have 2. Sorry, I made a mistake. It's 2 minus I here. So 2 minus I cancels with this minus 2 and 2 and minus I and I, which cancels to give us 0, so this gets eliminated. But this equates to negative 2i. And now we can write that this is equal to minus 2ci. Oh, let's write it with the real part first. It's 2d minus 2ci. Now if we equate, real and imaginary parts, we have that, and we only have a real on the left, so we have 2d is equal to 4, which gives that d is equal to 2, and we have no imaginary parts, so c is equal to 0. Now when x is equal to 2 add I, we have 4 is equal to a add bi, and that's times 2i, which gives us minus 2b add 2ai. Therefore we have that a is equal to 0. We have no imaginary parts on the left. B is equal to negative 2. Because minus 2b is equal to 4. Therefore, b must be negative 2. So we can write our original. Let's make some space for that. We have 4 over x squared minus 4x add 5 equivalent to minus 2i over x minus 2 minus I added to 2i over x minus 2 add I. Just to recap, we had that b was equal to negative 2. We had and d equal to 2. And we substituted those in those complex numerators in the previous part of this video. Thanks for watching. I'm Alistair. Bye for now.